Hi students, this is AJ sir. Let's study 10th standard ICSE Math chapter 14 exercise A, equation of a line, basics. Chapter 14 exercise 14A. Let's do question 1, Roman number 5. Roman number 3 is for homework. Cancel Roman number 1, Roman number 2, Roman number 4 and Roman number 6. Also cancel question 2. Find out which of the following points lie on this line. It's a linear equation. If we plot a graph of this on a graph paper, it will be a straight line. Something like this. We have to check if this point 2, minus 1.5 lies on that graph, that is on that line. Now instead of literally drawing a graph line and checking if this point lies on it, we can just do a bit of calculations and find out whether it lies or not. Remember, any point which lies on a line satisfies the equation. That means if I substitute the value of x as 2 and the value of y as minus 1.5, if I substitute them in the LHS, I will definitely get the RHS, which is 0 in this case. And if it is not equal, the LHS and RHS, that means this point does not lie on this equation. It won't satisfy this equation. So we start with the LHS. We substitute the value of x as 2 and y as minus 1.5. We solve and I get the answer as 10, which is not equal to RHS. Therefore, it doesn't lie on the line. Next, question 4. For what value of k will this point lie on the line? Now, if this point lies on this line, it means it satisfies the equation. It means I can substitute the value of x as 3 and y as minus k and solve to get the value of k. So here there is no LHS RHS because they've already mentioned that this point should lie on the line. We don't have to prove that it lies on the line. So understand the difference in the two sums we just studied. So here it lies on the line, so it satisfies the equation. Start with the equation, substitute, solve and get the value of k. Now question 5. The line, yes, even this is a linear equation. If I do LCM, I can get rid of denominators. This line contains this point. Calculate the value of m. So similar to the previous sum, it is given that it satisfies this equation. So I can substitute x as m and y as 2m minus 1. And note there is a minus sign outside here, so be careful about this minus sign. First step is to get rid of the denominators. LCM, that's what I'll do. And also substitution. So I get this equation in m. It's a linear equation. Be careful while opening the brackets. Minus and minus into minus is plus. Get all the like terms together, the numbers on the right hand side, and I get the value of m as this. Give the answer in mixed fraction in this case. Next, let's do 7.1. You can cancel 7.2 and 8.2. The line y is equal to 3x minus 2 bisects the join of this and this. Find the value of a. Let's assume there are 2 points P and Q. This is point P and this is point Q. I can draw a line joining them. And they have a midpoint, which I can find by using midpoint formula. There is another line, y is equal to 3x minus 2, which will pass through this line. And this equation, y is equal to 3x minus 2, bisects this line, PQ. That means this equation will bisect line PQ, and so the midpoint of PQ will lie on this line as well. So the diagram looks somewhat like this. This is point P and Q, and there is another line and it bisects it. So whatever is the midpoint, let's call it M. This is P, this is Q, and this is the equation. Which equation is this? Y is equal to 3x minus 2. So first I'll find the midpoint of PQ, and I know that this midpoint should lie on this equation. So it will satisfy the equation. Midpoint using the midpoint formula, x coordinate plus x coordinates average, y coordinate plus y coordinates average. I get the midpoint values. Now this lies on this equation. It lies on the line. So it satisfies this equation. That means instead of y, I will substitute -1. And instead of x, I will substitute a plus 2 upon 2. And now I will solve it further and get the value of a. That's what they've asked. Next, the 11th sum. Find the point of intersection of the lines this and this. And if this point lies on a third line, that, find the value of k. First of all, how do we find the point of intersection? Yes, you can plot two graphs and check out the point of intersection, but let's solve it using simultaneous equations. Because when we use it simultaneously and we get the values of x and y, then that is nothing but the point of intersection. So I took the two equations, the second equation I multiplied by 3 so that I can use elimination method, and 3 by 3 by gone, and get the value of x, and substitute in equation 1 again to get the value of y. And this point x comma y, which I got as -2, 3, is indeed the point of intersection. Now they are saying that the third line also passes through this point. That means it satisfies this equation. So in this third equation, substitute x as -2, y as 3, solve and get the value of k. And remember, whenever three lines pass through the same point, they are called concurrent lines. So in question 12, we have to show that these three equations are concurrent. That is, these three lines meet at the same point, not by drawing a graph, but by solving them. So first we'll take any two equations and solve them simultaneously to find their point of intersection first of all. I'm going to take the second and the third ones. I'll subtract it so that x goes away and y's value is obtained, and substitute it in equation 1 here and get the value of y. So the point of intersection x comma y is 3 comma -1. Now if only I can prove that this point lies on the third equation also, then it will be proved that all three lines are concurrent. But how do I prove if a point lies on a line or not? Well, we start with the LHS and see if it matches the RHS. So in this equation, the LHS is this. Substitute the value of x as 3 and y as -1, solve, and not surprisingly, it is indeed equal to RHS. That means this point does lie on the third equation. That means all three lines are indeed concurrent. Hi students, if you found this video useful, press the like button. Also, to enroll for my online lectures or online test series, email me or message me on Instagram. Check the description for more information.